Welcome back to another example on, it's not really a week, but this section's a lecture. So last video we finished change of bases, finding our transition matrix, which is kind of boring. The funner name is a translator, but whatever. So we finished with change of bases, and so now we're going to get into the second part of what we discussed about in the lecture, and it will be the rank nullity theorem. So this is probably going to be like 3 examples because they're straightforward. Like I mentioned, it's like once when you get the hang of one, or once when you know how to do one, the rest of them is just kind of like just keep on doing it, same thing over and over again. The only, I guess, difficulty would be the algebra because I'll admit, sometimes I don't, or sometimes I just can't add. You can probably tell by some of the videos where I pointed out what what I was doing wrong. But yeah, I had a good laugh after looking at them. But yeah, so let's get right into it. So for the first one, we are given a 2x2 matrix, and it is starting with 1 0 0 2. So like I mentioned, to even find the row space and column space, it's best to put them in row reduced echelon form, since when you do that, it won't change those subspaces. So we're just gonna go ahead and do that. Start it off like right off the bat. So you just divide by 2 on the bottom one. That's it. Wow, so simple. So our row space. If you remember from the lecture, the row space, we only look at the non-zero rows. So it'll be this one here and this one here. So our row space will be 1 0 and 0 1. Our column space, now we look at the pivots where the leading ones are. So it'll be here and here. So our column space is going to be, oh yeah, I forgot. With the column space, you look at the leading ones on the row reduced echelon forms, but what you end up getting as like what you write for your answer is you look at the original matrix. So it'll be this portion, this portion. So it'll be 1 0 and 0 2. What am I missing? The rank. Well, you just count the number of non-zero rows in row reduced echelon form. So we have 1 2. So we have our rank is equal to 2. And that means that our nullity will be 0. And that is because the nullity is just any row that is 0. And we have 0 rows. So nullity is 0. And we go back to the theorem, the rank plus a nullity is going to give you the number of columns, which indeed it does here, because we have 2 plus 0, which is 2, which is equal to the number of columns. And we have 1 column, 2 columns. Whoa. And this is going to be holding true throughout these examples. So we're just going to go ahead and move on to the next one. So the next one, we have in this time, a 2x3 matrix. Yo! And we're going to put this in row reduced echelon form. So let's get to it. So what we can do is, what can we do? We got a leading one, hopefully, here. So we could just cancel out this 4. So we'll have the top remaining the same, minus 4. So we're here, and this is multiplying by -4. So it'll be -3 times -4 is 12, plus 2 is 14. Then 2 times -4 is -8, plus 1 is -7. And, oh, beautiful, beautiful, beautiful. We can divide the bottom part by 2, not 2. Good job. By 7. So you have 0, 2, then -1. And then we can add twice the second row to the first row, which will cancel out this 2. So that'll be 0, 2, -1. And then you add double. So 4 minus 3 is 1. And then now I can probably squeeze it in here. We can subtract not subtract, divide the second portion by 2. So that'd be 0, 1, -1/2. So now we can get rid of this one. This one. Okay. We get rid of this one by just subtracting by negative for the second row. So we'll have in the bottom 0, 1, -1/2. Then we'll have 0 here. Then we'll have -1/2 times -1, which would be 1/2. And that is our row reduced echelon form. Now, again, our row space, number of non-zero rows, 1, 2. So row space is simply equal to non-zero rows. And you copy what you see in the row reduced echelon form. So this would be 0, 1, -1/2. Yeah. And then I forgot what color I used. Column space, this is yellow. Column space, column, is that how you spell it? Column space, well, we first look at our leading ones, which would be right here and here, and then we just correlate them to back the original matrix. So here and here, so that'll be 1, 4, and -3, 2. And then our rank is, well, count the number of non-zero rows, 1, 2. And then our nullity is nullity, I think that's, I forgot how to spell. The nullity, well, it's gonna be 1, since, I mean, like I mentioned before, the number of columns has to be equal to n, which is equal to 3. So the nullity will be 3 minus 2, which is 1. But another way you can see it is, oh my gosh, why is it turning like this? There we go. Another way you can find the nullity is you kind of look at it in terms of, you look at this matrix like a system of equations. So you have 2 equations, 3 unknowns, and so you're gonna have 1 free variable. And so that free variable will be in the kernel, which is what the dimension of the nullity is, because it's 1 variable, so it's gonna be 1. So the dimension will be 1, which is the nullity, which is 1. But I mean, if you want to think of it like that, by means go ahead. But the more like sanity type, like this is gonna be right, is that the nullity is gonna be some number plus the rank that's gonna equal to the number of columns. But yeah, so that is our second example, and then squeeze in one more. It's a little bit longer, but I mean, it looks easy, I think. Oh, I think I wrote this wrong. There should be a -4. All right. So now again, we have to find the row space, column space, the rank, and nullity. So let's just jump into it right away. And the cool thing, yo, this, and this, yo, they're pretty much the same. So like, you could cancel them real quick. We got 3, -6, -4. I'm gonna cancel the bottom ones. or 0 out the bottom ones. And so you're just left with 0, 0, 0. And this is going to be 9 minus 5, 4. And then, well, I mean, we can divide by 4 here, but we can get rid of this one too. So, that is an ugly 4. There you go. So it'll be -2, -4, 4, 5, 3, 6, -6, 0, 0, 0, 0, 4. And then, so I'm gonna like jump a couple steps. So what I'm gonna do is divide this by 3. No. Maybe. Should I? Maybe. Yeah. So divide this by 3 and then 0 out this 5 with this 4. So what we're gonna end up getting is 0. Oh, and then divide 4 by 4. 0, 0, 1. And this would be 2, not 2. I divide by 3. 1, 2, -2. This is 0. And then this would be -2, -4, 4, 0. So, a quick little recap is I divide by 4 for row 3. I divide by 3 for row 2. No, 3. And then I also subtracted R1 minus 4R3. So, yeah, this was the first step, second step, and this was the third step. No, not 4, it's 5. 5 R3. There we go. Alright, cool. Now let's get back to this. So now, well, row 1 and row 2 looks like it's a multiple of each other. So what we can do is 0 this, because you're just multiplying it by 2. 1, 2, -2, 0, 0, 0, 0, 1. And we're done. Yo, row reduced echelon form. Here we go. Now we gotta find a row space. Again, non-zeros. Rows. So our row space is going to be 1, 2, -2, 0, and then 0, 0, 0, 0, 0, 0, 0, 1. Column space, look at our pivots here and here. So it's going to correspond to this one and this one. So our column space will be -2, 3, -2, right? And then 5, 4, 3, 2, 1, 5, -4, 9. What's our rank? Non-zero, so 1, 2. Rank is equal to 2. And then lastly, our nullity is going to be here and here, which is equal to 2. Since it's 4 columns, we have 2 on the rank, so 2 has to be nullity. And so that's pretty much it for the rank nullity theorem examples. I might do more examples in terms of the column space, or like the system of equation where we talk about A x is equal to b, and we look at the cases where it's like what the column space means with if b is in the column space, or if it's not, and like what that means. I'm not really sure if I'm like kind of sort of already not Nah, not kind of, like I am behind schedule, just like a couple of days. But I mean, it's fine. In the meantime, I'll see you guys in the next video.